Just to see whether you have understood the recording session number one or not. Easy question only. And I will solve it also afterwards. So check out this question, everyone. Question is: a coin is released inside a lift and at a height of 2 meters from the floor of the lift, and the height of the lift is 10 meters, and the lift is moving with a constant acceleration this much downward. The time after which it is going to strike the lift, we have to find it out. So all of you try it once, then I will solve it. Okay. And also I needed 1 minute to fix things here. That is also the reason I'm giving that question to try. And essentially, everyone try. Just a moment. Okay, I hope you have tried this question now. So since they have told us the initial velocity, the one that coin is having with respect to the frame, no, it is given the coin is released. Released means something going to start moving from rest. But So with respect to what frame it is going to be appearing moving at rest will be from the frame of the lift. No? So they are forcing us to solve this question by being in the frame of the lift, which is not a stationary frame, which is a moving frame, correct? So whatever equations of the motion as you have seen in the recorded session, or whatever the equations we write for the motion when we observe from the ground frame, same equations we are going to use in case if we observe something from a moving frame. Only the difference thing will be we are going to use, or every term in there will be a relative term. No. So check out here what is the case here I have. So we are going to observe things by being in the frame of the lift, and it is told that lift is having an acceleration how much, this much downward. So let's check out what are things we know. We know the acceleration of the coin with respect to the ground frame, no, that we know, and that is going to be how much in g, but which way it is having that g downwards, correct? Maybe 1D motion, no, and so we might use some sign convention, and maybe I will stick to the same sign convention that upward I will consider it as positive. If I consider upward as positive, then the acceleration of the coin, the one which is with respect to the ground frame, is going to be minus g. So once anything is in air, its acceleration with respect to the ground will be g downwards. No. Now what is given next is the acceleration of the lift with respect to the ground frame is also given to us as 11, but again which way it is downwards. Downwards is like negative for us, so minus 11. And maybe I will take g as 10. Okay, so it's going to be minus 10. So first job will be, so since we are going to observe things by being in the frame of the lift, so what really we do? First job is to figure out the velocity, the position, and everything with respect to the frame of the lift. So if I'm going to consider things from the frame of the lift, so what really we do? We consider lift to be something which is not moving at all, no? And everything is going to be moving with relative velocity and acceleration. So from lift frame, we are supposed to figure out things. So the initial velocity of the coin with respect to the lift is something told to us that is 0. The acceleration of the lift, what lift? Acceleration of the coin with respect to the lift will be acceleration of the coin with respect to the ground frame minus the acceleration of the lift with respect to the ground frame. Acceleration of the coin with respect to the ground frame is minus 10. And the acceleration of the lift with respect to the ground frame is minus 11. So the answer that we get here is minus 10 minus of minus 11. So plus 11, that will be 1. No? So it means the coin is going to be moving with this much acceleration with respect to the frame of the lift. One more thing is missing that we have to find out the initial position of the coin with respect to the lift. So it is basically solving a brand new question in which the lift is going to be remaining stationary while the coin moves with relative velocity and relative acceleration. So how to solve this question? Same way as you solve any question from ground frame. So this is the frame of the lift. This is the lift suppose we have. And what it is told, let's check out. The height of the lift is 10 meters and this object is released from a height of 2 meters from the floor. So this object is released from a rest at a height of 2 meters from the floor of the lift. Total height of the lift is 8 meters. So that remaining length will be 8 meters. No. Now, literally what we are going to do is we'll think the lift is not moving. Only thing that is moving in here is that coin. And with what it is moving with? 1D motion, we got acceleration of the coin to be +1, man. +1 means what? Plus here means upward, no? So the acceleration of the coin with respect to the lift is +1, means it is upwards. So it is going to become a question in which an object is supposed to be starting from rest and then continues to move with an acceleration that is 1 meters per second square. Isn't it obvious that this object will be hitting not the floor, instead the ceiling of the lift? Clear, no? This thing, man. Which is the place, what really the location where it will be hitting the lift will not be the floor of the lift. I hope my voice and everything is going okay, no? Do you see any delay? Yeah, there's a delay. I'm also watching it my phone. Maybe there's a delay, you tell me. I will not know if there's a delay. So tell me, whenever it is going to hit the ceiling, the displacement it is going to undergo is going to be this much or not? Tell me, what is the relative acceleration he has? Is it something constant or not? Constant. So if acceleration was constant, what formulas were applicable? Same formulas are applicable here also. Relative acceleration is constant, so I'll be using S relative equals U relative t plus half A relative into t square. Just here I am going to use the relative thing to be the displacement of the coin with respect to the lift. That's going to be equal to initial velocity of the coin with respect to the lift into t plus half acceleration of the coin with respect to the lift into t square. No, so much. I pretty small. The writing is like so headache. Okay, I hope you're able to follow. Here u will be made equal to 0. So what we get is displacement is 8 half into 1 into t square. So the answer came t square equals 16. So what answer will be t equals 4 seconds. I hope all of you understood this question. All of you understood, no? Okay. So I hope you don't hear water sound also, no? It is my week off. I thought, man, what to do to take class also and week off also. So I came to beach here so that maybe I will see the beach also and I will take class also. So I hope you're see listening. Audio is going clear, no?
Yes, sir.
So okay, I'll take a new page now.
Sir, your audio
The
is
thing that I
breaking,
wanted,
sir.
audio is breaking.
Yes, sir.
Okay, I've experimented that. Just a moment. Okay, maybe I will disconnect from my phone. It's like now audio is better. Now audio
Sir, your voice is still breaking, sir.
and just a moment. Hey, is it fine now?
Yes, sir.
It is fine now. Okay then. Okay, next thing
No,
is
sir.
thing that
Now
I am
okay,
going to
sir.
still break. Okay, no. But then in case something happens, you tell me. Okay. phone, WhatsApp. Just a second. So the thing that I'm maybe have a look at thing while I join from. Just a second, man. Okay, I'll take a new page. Just give me a minute. Just make like this. Just a second. Screen sharing is out, man. I think things are going to be finer now. I think I'm audible properly now. No?
Now fine, sir.
Yeah, joined with other network one then only. Yeah. So we are going to discuss something called as riverboat problems. So the things that I'm going to use, the symbols I'll write down. VB here stands for the velocity of the boat with respect to the ground frame. VS stands for or Vs, I'll write down here only. Vs or Vb stands for velocity of the swimmer or velocity of the boat with respect to the ground frame. Now VR will be used for velocity of the river with respect to the ground frame. So how much someone swimming in the water, flowing water or river is going to travel with respect to the ground frame, for that what we are going to need is the velocity of that thing, the boat or the swimmer, with respect to the ground frame. No, correct? So what really the things will be given here is, suppose if I write down velocity of the boat with respect to the ground frame, sorry, with respect to the river, or maybe in case of swimmer is the case, we have VSR. So this will mean velocity of the boat or swimmer with respect to the river. So velocity of the boat with respect to the river, if I have to write down in terms of velocity of the boat from ground and velocity of the river from ground, what it will be, VBR will be VB minus VR, no? So always, most of the time, every time, the end goal will be somehow you find what is the velocity the boat has with respect to the ground frame. So you see, VBR is equal to VB minus VR. So VB will be equal to VBR plus VR, no? So velocity of the boat with respect to the river, if it's all given, and velocity of the river given, then we can figure out whatever the velocity the boat has with respect to the ground frame. The first case will be, it's like 1D case. So I'll take a new page for that. I'm going to share this PDF, so don't worry about writing down the notes. Maybe after the class, you must write down. The 1D case is like some escalator that is supposed to be not that escalator, that staircase one is going to be like a escalator, that horizontal one. Okay. Suppose if I tell you the velocity of the boat, okay, first I'll tell you, suppose velocity of the river is this side. And if the velocity of the boat with respect to the river is in the same direction as the velocity of the river, we call it as a downstream case. Suppose if I use VR as, I'll write down VR as U and VBR as V. And 1D case it is, so maybe I will take this side as positive. And using this as the sign convention, what is the velocity of the boat with respect to the river will be? That is going to be equal to plus V. And what is the velocity of the river will be? That is going to be equal to plus U. So adding both of these two, the velocity of the boat with respect to the river and the velocity of the river is going to give us the velocity of the boat from ground frame. So that will be U plus V. Correct. And what it came out to be plus of U plus V, no? So plus is taken as the downstream case, or that is the rightward direction in this case. So it is same like suppose if the escalator is making you travel this side by 5 meters per second. And suppose you are remaining stationary on top of that, then your velocity with respect to the ground will be same as the velocity of the escalator. But in case on top of that escalator, you're running on it with a speed, suppose 20. So the escalator will make you travel rightward by an amount of 5 in 1 second. And on top of that, you travel 20 in the same direction. So how much you will end up traveling with respect to the ground frame will be 25 meters in 1 second in the rightward direction or in the direction of the escalator. No? The same sort of thing is happening in here. So this is the case which is the case of downstream. Another case is the case of upstream, means moving against the flow. Suppose the velocity of the boat with respect to the river is this side, opposite to the way river is flowing. And maybe he is moving this side, maybe this side is like more interesting direction for us. So upstream direction, I'm going to take it as positive, or leftward direction, I'm going to take it as positive. And using this as the sign convention, if I ask you, write down what is VBR vector is, that will be plus V. And with same sign convention, write down what will be VR vector will be. That's going to be equal to minus U. So sum of these two is going to give us the velocity of the boat with respect to the ground frame. That will give us, so we have VBR, we'll write VBR first, VBR plus VR. So that is going to give us V minus U. And if at all this quantity is going to come more than 0, when it will be, when V is more than 0, sorry, when V is more than U, you will find that value of VB is going to come positive. Positive here means leftward direction, or it is going to travel in the upstream direction. In case if V is less than U, you will get VB to be coming equal to P something negative. So that is going to be the downstream direction. So this is going to be like easy thing only, nothing much. So I will give you a question which is of Hirodo and you will try it, and after trying you might get stuck. Then I will discuss it also. Just like first question of this book. Okay. Not this one. I know the question, like I remember that question, but I wanted to show you the exact question. Done this question, I don't know how many times. So my teacher did this question in his class. I'm also doing this question in my class. So motorboat going downstream overcame a raft. So if I tell you raft, raft will be something, the one which will be stationary with respect to the river, floating and moving along with the river, no? So velocity of something which is raft with respect to the river will be 0. So velocity of the raft is going to be 0, and velocity of the raft with respect to the ground frame is going to be same as velocity of the river only with respect to the ground frame. Just I'll explain the question, but you must try. And not like I'm giving this question that you will be able to solve. You try once, and totally, if you're not able to solve, fine. We will discuss it in the class. A motorboat downstream overcame a raft at a point A, and 60 minutes later, it is going to turn back. Okay. And after some time, what he sees that the raft has traveled a distance of 6 kilometers from the point A where he saw the raft for the first time. And from that much thing given, they are asking us find the flow velocity of the river, means the speed of the river, and duty of the engine, you assume it to be constant. So what really this word means that even though you're traveling downstream or upstream, the speed of the boat with respect to the river that is going to be remaining same whether you travel upstream or downstream. Okay, so try this question. Or one more thing I will mention. Sometime it will be told so like something like this: a swimmer can swim in still water with a speed 5 meters per second. So that is a way of telling you that velocity of the swimmer with respect to the river, or the velocity of, not velocity, the speed of the boat with respect to the river, or speed of the swimmer with respect to the river, is equal to 5 meters per second. So there is some language thing you should know. So if you see such statement that a boat or a swimmer can swim in still water with this much speed, it means they just indirectly they are telling us the speed of the boat or the swimmer with respect to the river. Okay. So I'll take a new page. You must try this question maybe today. Give 10 minutes at least. Then I will discuss it. Don't Google it. Obviously, you will get the solution. Okay, then next thing is, suppose I have a case when the swimmer is supposed to cross the river, not like he wants to just go upstream or downstream. Suppose if I have a river whose width is told to us, that width of this river is B. And suppose from this point, the boat is starting to move. And it is given that velocity of the river is this side. So for VR, I'm going to use the symbol U. VR is this way. The boat starts to move from this point, maybe I call it as A, and the velocity of the boat with respect to the river is this way. It means the boatman is trying to steer his boat in this direction. Okay. And what really we know, or what really the thing that we want to know is velocity of the boat with respect to the ground frame to know how much the boat will end up traveling as observed from ground frame. For that, what we have to do is to add the vector which is VBR and VR. How to add the vectors depending upon whatever is comfortable thing for you. Maybe we can do addition by finding them out in terms of the components, or maybe we'll use triangle law or parallelogram law, whatever is comfortable for us. Or maybe both of them we can use simultaneously also. So maybe I want to use parallelogram law. So I will draw our VR vector here only. Now, to add this two vectors, so now we have to trust the math that if I add these two arrows, the resultant of these two arrows, whatever he might be, it must be lying somewhere in between them. No, so this is the blue arrow. This is the resultant of VBR and VR. Now, if I tell you that VBR vector is constant with respect to time, VR vector is constant with respect to time. So whatever that VB vector will be, it must be also constant with respect to time, not changing with respect to time. So due to that, if I ask you that VB vector will be always directed in the same direction. So if I extend the arrow of VB vector and it is going to intersect the bank here, then maybe that point is, maybe I call it as P. And if I extend the arrow of VBR vector, or if I check out the line along which it is acting along, and that line is, suppose I call it as AC. That's not a nice line, man. Just don't enter it nicely. So this point is C. So now the question arises that if I am an observer which is in the frame of the river, maybe something like a raft, someone like floating in the river, moving with the river, the one which is stationary with respect to the river, and that observer, if he is observing the boat, he will find the boat to be moving along this direction. Why? Because that is the direction of the velocity of the boat with respect to the river. So this is the direction in which the boatman will be trying to steer the boat. Now, if someone who is observing the boat from the ground frame, he will find the boat to be having velocity VB, and that velocity VB is along the line AB. So AB is the path, the one which is seen with respect to the ground frame. And what really that is the actual path, no? The one that we want to find, the one in which we are interested in. Okay, now to solve these vectors or to find the sum of these vectors, we do some math thing. Maybe I consider the starting point as origin, and maybe this is our x-axis, and this one is our y-axis. And the point from where he starts, that is our origin. So the point B is the point where the boat actually reaches. No, this is the point where the boat actually reaches. Just like in the upstream or downstream case, the velocity of the boat will be found by adding up the vector VBR and VR. So boat might be doing something else with respect to the river, but what will be seen, whatever he will be seen doing from ground frame, which vector will be telling us that thing? It is the velocity of the boat from the ground frame. So somehow we found that VB vector is along the line AB. It means the boat will be seen traveling along this arrow or along the path AB when observed from the ground frame. So whenever he reaches the other side of the bank at point B, what is the y coordinate he will be having? Tell me. The y coordinate will be the width of the river, for which I'm using the symbol small b. Is it not? And the point which is opposite side of the bank is this point A dash. So how much he has traveled in the direction which is x-axis direction or along the river flow direction, he has traveled A dash B length. No? And that is something which we call it as drift. And the symbol I'm going to use for drift is R. So tell me what is the x coordinate of the point B will be R, no? So now next job is to find the sum of these vectors, and I'm going to use the symbol U for VR vector and symbol V for VBR vector, because who will write VBR again and again? It will be like so headache, no? And okay. So now suppose in case if I tell you this angle is alpha. So just the job here is to write down the vector VR and VBR in terms of their components. So VR will be like easy thing to write. He's like totally only acting along X. It's going to be U I cap, correct? Now if I decompose this vector VBR, it has two components, one along Y and another along minus X. The minus X component is V sine alpha and plus Y component is V cos alpha, no? So the velocity of the boat with respect to the river, that is going to be minus V sine alpha I cap plus V cos alpha j cap, is it not? Now we will add these two vectors. If I add these two vectors, what we get is VP vector, no? The velocity of the boat with respect to the ground plane. And that is going to be U minus V sine alpha I cap plus V cos alpha j cap. So the moment you know this vector, then nothing much is there in this problem after finding it out using Wi-Fi. Okay, I can take a new page now. I hope up till here all of you have understood things.
Yes.
Now just I will write that VV vector that we have got. So once you get that VV vector, now what it becomes a question where a particle moving with constant velocity along x, which is this much, and constant velocity along y, which is this much. So if I tell you there's a particle moving with constant velocity along the line AB with what speed VB, then how long it will take to reach the point B from point A? It becomes such a simple question after that. So what is the velocity the boat has got in the x direction? That is U minus V sine alpha. And what is the velocity the boat has got along y direction? That is V cos alpha. Once you get this, forget about it is riverboat question, man. Think it is a question in which man is simply walking on the ground with this much along x direction, this much along y direction, and that too constant, man. Not even with acceleration. So what is the thing which will guarantee us that the river is crossed? Tell me. Once we reach the other side of the river, bank, what really the
Your voice is breaking.
Hmm.
आ गया
Hmm. Okay, it got disconnected, man. Sometimes network goes off. Will not try this thing again. It's like risky. I hope I'm audible properly. I'll repeat whatever I've told. The moment we know the velocity of the boat with respect to the ground frame, it is going to become a question in which I know a particle is traveling with constant things along x and constant things along y. So, I'll, so first thing that we have to find time to cross the river. Tell me when river is crossed, the displacement along the y direction will be equal to reverse width or not, and how much is the reverse width we have taken as p. So displacement along y, what really will write down. So since there's no acceleration, no, so displacement equals velocity into time. So displacement along y will be velocity along y into time. So displacement b velocity along y is how much? V cos alpha into t. So what t is equal to b by v cos alpha. Simple thing only. You don't have to remember any of this. Anytime you need, totally you can derive it in your head itself. How come you can forget when river crossed the displacement of the boat along y direction will not be equal to reverse width? You can't forget that. And finding out the velocity in the y direction, it's like so simple, just v cos alpha. So time to cross the river, pretty simple thing to find, no? Next thing is, how much is the drift that we are going to have, the displacement along the flow of the river? So tell me that how long projectile was traveling along its direction. For whatever long it was in air, correct? Same way here, how long he will be flowing or moving in the direction of the river flow as long as the boat is in the water. So really the drift is, so what was the range? The total displacement along horizontal. And the first thing was there to find out the first thing that we are supposed to figure out was time of flight. Same way, the first thing I have to find the time to cross the river. So I'll try to adjust that thing also. So drift is the total displacement. So for drift, I'm using the same symbol, the one we used for range. So that is the displacement along the river flow, which is the x direction in the time, which is equal to time to cross the river. And what is the acceleration we have along this direction? 0. So what displacement will be? Velocity into time. And what is the velocity we have? That is u minus v sine alpha. And what is the time to cross the river is d by v cos alpha. So finding out the time to cross the river and finding out the drift, I hope it is easy thing to all of you. I hope whatever is done in this slide, it is like all of you have understood. It could be like confusing also, man. So you can think like this, the boatman is trying to steer the boat this way, but which way he will really end up moving? He'll end up moving along the direction of BB. Suppose if I take a case, suppose upper stream case I have, and velocity of the boat with respect to the river is suppose 5, and velocity of the river is of magnitude 7. So in this case, what really the velocity of the boat will be? So we take out this result, v minus u. So v is 5, 7 is u. V minus u will be 5 minus 7, that is minus 2. Minus 2 means he will be moving downstream direction. So tell me, what really the thing that boat is trying to do? The boat is trying to travel this side with 5, correct? But which way really he will end up traveling? Opposite to that with what rate at 2 meters per second. So the boat will be trying to travel this way, but in what direction the boat will end up traveling really will be given by the velocity of the boat with respect to the ground frame. Correct? So just I have to understand the direction in which the boat will be seen traveling will be given by this vector. Then we should trust the mass. That somehow we find the sum of these two vectors with whatever mass thing we are comfortable with. But once we get this thing, it becomes a very simple question. Once we get VB, it becomes a question where a man is walking on a horizontal surface with what speed? With speed VB. Along what direction? Along direction AB, the direction of the arrow of VB. So that much simple question it is once you get the VB vector, that's all. I hope this all things are clear to all of you. Okay, I'll take a new page now. The next thing is, suppose I want to cross the river in minimum amount of time. Maybe I want to stay in water for less time. Maybe water is like so cold. And if someone remains in water longer, cold water, they may get hypothermia or something. So we want to like minimize the time to cross the river. So one way to look at that thing is we can like totally see the result that we have. Time to cross the river is B by V cos alpha. Correct? So one way to do this thing is like you can totally see B is not going to change. V is not going to change. Only thing I'm changing is the angle, maybe alpha. So to minimize t, I must maximize the denominator. No, for t to be t minimum, cos alpha must be maximum, and the maximum it can become is to become equal to 1. When it will become equal to 1? When alpha is going to be equal to 0 degrees. So for that case, if I draw the diagram, alpha, you check out what is the alpha really is. Alpha is the angle made by VBR vector with the y direction, no? So if alpha 0, VBR vector will be lying in the direction which is y. So this way is our VR vector, and this way is our VBR vector. So in this case, the angle between VBR vector and VR vector is going to be how much? 90 degree. So when we cross the river in minimum time, the angle between the VR vector and VBR vector is something which is equal to 90, no? So VBR vector is V, this is our U. So for this case, if I ask you, write down the velocity of the boat with respect to the ground frame. And that is going to be U I cap plus V J cap, that's all. So in this case, if I have to find how much drift the boat will undergo, so in this case, what really is happening, this is our point A, this is our point A dash opposite point from where he starts moving. So he will be trying to reach here, okay, because always he will be trying to steer the boat perpendicular to the flow. But where he will reach, that will be decided by the VB vector. Some of such VBR and VB vector will be lying somewhere in between them. So the point where he really reaches is this point P. So how much the drift in this case he is going to undergo? So it's like easy. What is the minimum time is? Minimum time is B by V. And what is the velocity the boat has got along its direction u? So it will be u into v by v. So you can plug the alpha as 0 in this expression also. Put alpha 0, what you get drift as u into b by v. So when we cross the river in minimum time, I hope you have understood that how come drift is this much and why that minimum time is b by v when alpha 0. So maybe you can have another outlook also here. So for that I will take a new page and there I will draw. So component of a vector, what really tells us the effect of the vector in that direction, no? Suppose if I take a 1D case, okay, and suppose I want to remain stationary in water at one place, and VR is suppose 3. So with what VBR, you must travel in opposite direction, must be 3 only or not, correct? It means for in order to travel, okay, maybe. So what really this vector is doing now is acting opposite to VR vector, no? Okay, now next thing is suppose if you are traveling at some angle, so our VBR vector directed this way, which is of magnitude V, and this angle alpha. So the effect of this vector along x direction will be V sine alpha. And effect of this vector along y direction is V cos alpha. And VR this side, no? So VR has no component along y direction. So in case if he is only moving in the upstream direction, so what really this velocity vector does, it is to fight the river drift or not. So whatever the velocity vector does in this situation, same thing, the component of VBR in this direction is going to do the job. Now, in this case, we cannot cross the river because the boat will not be having any direction, any velocity in the y direction. That's why we are traveling at some angle so that one component V sine alpha using which we fight the river flow and using V cos alpha we cross the river. So if I want to cross the river in minimum time, I must make this thing to be maximum. No? You can think like this. We are putting our effort in this direction. A part of effort is utilized in fighting the river drift along plus x direction. A part of the effort is used to cross the river. So when I want to minimize the time to cross the river, then all effort should be kept in order to cross the river. So in that case, what should be alpha then? 0 only. I hope this reasoning, all of you have understood why alpha should be 0. I want to keep all my effort in crossing the river. I want to keep all my effort in y direction only. For that, VBR must be making what angle with y direction 0, no? Okay, then. Next case is the case of 0 drift. Zero drift means when we want to cross the river without traveling anything along the river flow. So for zero drift, velocity along x should be 0. Velocity along x, how much we got it as? U minus V sine alpha. So for that, sine alpha should be equal to U by V. So you can understand it like this also. Suppose if I keep all my VBR in upstream direction. So in order to travel nothing along the river flow, VBR magnitude should be VR to cancel out the effect of VR. Now I am having my VBR at some angle like this. So the component of VBR along minus x now should be cancelling out VR, no? So what is happening? This way is our VBR vector. With one hand or with one component, he is fighting the river flow. With other hand or the other component, he is crossing the river. And I want to cancel out the effect of the river drift or effect of the river flow. I must have V sine alpha to be equal to U or not. And tell me V sine alpha can be equal to U only when V is more than U, no? Suppose if I have a case V which is less than U, suppose. Sine alpha, is a quantity less than 1 always. Alpha is something less than 90. So sine alpha less than 1. So V sine alpha is guaranteed less than V. If V itself is less than U, then how come V sine alpha can become equal to U? So V sine alpha can become equal to U only when U is lesser than V or not. Or we can say other way around also. Sine alpha can never be more than 1. So only when sine alpha can be equal to this when U by V is not more than 1. When U by V is less than 1. So when U by V less than 1 means what? When speed of the boat, no, speed of the river with respect to the ground frame is less than the speed of the boat with respect to the river, no? Correct? So zero drift not always possible. Only possible when the speed of boat with respect to the river is more than the speed of the river. Obviously, from what frame the speed of the river we are talking about is with respect to ground frame. So in the case when we cross the river without having any drift, so from wherever we start from one side of the bank, we'll be reaching the opposite point of the bank. No, suppose we start from A, then where we will be arriving? We'll be arriving at A dash. So VBR vector, where is different color? This violet or purple, man, what it is? So this is our VR vector, and this one is our VBR vector, and this is our angle alpha. The resultant of these two will be lying entirely in the y direction, and that is our VB vector. So in this situation, if I ask you, find the time to cross the river, so that you can totally find, since sine alpha given, you can determine what will be cos alpha. Cos alpha will be root over 1 minus sine square alpha, and that is going to be equal to v square minus u square root over by v. So time to cross the river is equal to b by v cos alpha. Plug the value of cos alpha, answer is b by root over v square minus u square. One more important thing to notice here is the angle between VR and VBR vector is how much? Angle between VBR, not VBR, VR and VBR vector is 90 plus alpha. Suppose that angle I write down as theta. So theta equals 90 plus alpha. So if I ask you find cos theta, what it will be? Cos of pi by 2 plus alpha. And cos 90 plus alpha is minus sine alpha. So that will become minus sine alpha. So in case of zero drift, the angle between VR and VBR is equal to, so what is sine alpha? We know that is minus of u by v. So theta is equal to cos inverse of minus of u by v, or that is equal to cos inverse of minus of vb by vpr. I hope all these things all of you have understood. Any doubts anyone is having? So even though riverboat is still not over, man, relative motion very lengthy. So maybe 3 or at least 2, maybe 3 more classes more will be required to complete all the theory. That's why I'm taking like some class I'm taking for weekends, some weekdays, then I'm clubbing them together. So whenever I ask you watch the recorded session, you must watch the recorded session. Then only I can complete things on time. It's not like I'm lazy to repeat the things. I'm not at all lazy for taking class. Just because we can save some time for that purpose, I'm asking you to watch the recording. If you don't understand something, totally we can discuss. So anyone having any doubt in whatever we have discussed in here? All of you understood, no? Karthik understood, no, man?
Sir.
Shaktivel understood, no? Shaktivel, you're able to follow, no? And
Yes, sir.
then, even though you have not completed vectors module, still you are able to follow. That is nice. Okay. So if you could have started from the beginning, you must have been doing like very good now. But still, after 1-2 months, max 1 more month maximum, you will become totally comfortable. Not 1 month also. Maybe 20th August like that, because on 15th August we will get the time now. So there I will complete. By that time, maybe backup will get over. Okay. So anyone having any doubt? If no doubt, I'll give the homework, and you must try the homework. Maybe you are unable to solve even one question, no problem. Is what is the purpose is. If you're able to solve all problem, then what I will do, man. So it's not like I want you to solve question every time. Then what is my job then if you can solve everything on your own? So what the point now? So it's not like some teacher giving homework, they want you to solve all the questions. I want you to get stuck in some questions, then only I will enjoy solving it on the board, no? Got the point, no? Just a moment, I'll write down the homework, which is very essential that you should solve it today. Tomorrow you will solve it is less beneficial than if you solve it today. And that erode question I have given, you must solve it. Next class, I will start the class with that question. Just a moment, I'll give the homework. First, I will write the exercise questions. So maybe 90% question you're not able to solve. 90% I will discuss, but you must try. Exercise 1, question number 2, question number 3, question number 4. Still some theory of this thing is pending. It's not totally over, but you will not be seeing any question based on that theory which is pending. Okay, that's why sometime if I don't teach something or I'll teach everything, if some teacher will not teach something, you can't tell also what is not taught to you. Okay, because maybe question based on that thing which is not taught in the class, not there in the module. So question number 2, 3, 4, 6, 9. So see, it is told that to cross the river in shortest distance. So in every question will be the case when you cross the river with zero drift. Okay. Then we have question number this much only in exercise 1. Exercise 2, question number 2. Just a second, man. It's like, just give me 1 second. So one day you get, and that day also, we teachers are keeping backup class now, and it's like so bad. But what to do? That is what is the life of student teacher is always. Exercise 2, question number 2. And then exercise 2, question number 9. Question number 11, 12, 13. You may not be able to solve, but just give it a try, okay? because it has got some calculus things also in there. That's why. Just give it a try, but don't Google it. Just give it a try. Not able to solve, nothing bad. Go to next question. Your job is to try, not to get the answers. Always. Exercise 3. And exercise 3, no question of about. Okay. Beginner box also. Just the moment I'll open beginner box. Just laws of motion. Even try the illustrations. Okay. See, beginner box 1, I have not done first. I have done beginner box 2 first. So beginner box 2, questions are either rainman problems or either riverboat. So beginner box 2, all the questions. Okay. And check out illustration number 3 to 5. Okay. So this is your homework. Anyone having any personal doubts, they can ask totally, man. Anyone having any doubts? So anyone missed classes because of some reason, you must inform me personally always, because my memory very bad, man. Because I don't want anyone to be not getting at least an IT. Okay. For that, I don't know any backup number of classes I have to give, I'll give. It should not be my fault. Never should be my fault that you should not be getting a good college at least. So if you miss some classes because of some reason, you must be upfront and tell the teachers directly. Okay. So when so many people are like irregular. Okay, then we'll end the class. Bye everyone. Thank you for coming to the class. I'll tell you the next class timings. Bye bye. Good night.
Nice.
Bye, sir.
Good night, sir.
Sir, what are the portions for the minor test 4, sir?
Projectile and drawing free body diagram.
Sir, but then it's still given as relative motion, sir.
Given no, you what I'm telling is correct. Okay.
Okay, sir.
You know, because different center, different customization. No, that is given in general. That is like stipulated thing that everyone should finish. But it's
Okay,
not
sir.
like even if time is not enough, just for the sake of finishing, will not be finishing things. It is not how things will happen in my class. So that's why I reduce the things. You know. So whatever we have done maybe till last class, just drawing free body diagram of tension, normal contact force, that we have seen already.
Laws of motion, okay, sir. But then this relative motion.
No. Projectile motion and the laws of motion things, whatever will be completing till Friday. That's much only. Then
Okay,
fine.
sir. Then.
Then fine. No.
Yes, sir.
Okay then. Okay. Okay then. Bye everyone.
Bye. Thank you, sir.
Okay, Rishi, Devesh, Abhinav, Saktivel, any doubt, man?
Okay, sir. Bye, sir.
Any doubt in the module you can ask, no problem.
No doubt, sir.
Okay, then please. Okay, go home and like what go home, you're at home only. Go and like solve the questions, man. Can only go to bed. Try all the questions, give 2 to 10 minutes, and then you will go to bed, okay? Bye bye.
Okay, sir.